We'll start the new topic, Kubernetes. Okay, so it is quite different. Okay, and one of the hard topic. Okay, in the DevOps course, or you can say in a cloud DevOps course. So you must have seen this logo. Okay, so this is the logo for Kubernetes. Okay, and it resembles this symbol. Okay, he, uh, he's a ship pilot who is managing a ship, okay, which is full of containers. Okay, so it is his role that the containers are properly placed, okay, via ship at the destination. Similarly, Kubernetes also makes sure that the containers are placed properly. Okay, so how is Kubernetes related to containers? Till now, we have seen how to host a website on a EC2 instance or a VM. Then we saw it using Docker. Okay. Then we saw it using Docker Compose as well. Okay. And now we'll see how to do that using Kubernetes. Okay. So for hosting one website, we'll host it on a container. Okay. And if I need one website, then I'll host one container. If for second, I'll do the second. Okay. Similarly, for various containers, I'll be using means for various application, I'll be using different containers. Okay. And in case I want to manage thousands of containers or hundreds of containers, okay, so manually managing it is not so easy. Okay. So to manage those containers, okay, to manage it scalably means it should be always in high availability mode. Okay. uh, and to orchestrate it, okay, there will be various complexities in managing the containers and all. Okay, so scaling, complexity, administration, okay, making it highly available, all these things are part of orchestration. Okay, so Kubernetes is one of the orchestration platform which helps us in managing the containers. Okay, the simple answer is we need to manage the containers properly. Okay, that's why we use Kubernetes. Okay, so what is Kubernetes? It is a scalable, viable, and self-healing container. Okay, so we'll be seeing a demo of self-healing. Self-healing means due to some reason, if the container dies, okay, or it is not responding, Kubernetes will make sure that it is restarted properly, or it will make it run properly. That's the feature of Kubernetes, one of the main features of Kubernetes. And it is the orchestration platform for managing the complexities of the containers. Okay, and it is also sometimes shortened as KATS. Okay, most of the times I'll be writing at KATS. Okay, so why? Because there are 8 letters between K and S. Okay, in Kubernetes, that's why it is also called as Kubernetes. Okay, so in short, Kubernetes is used for managing the containers, or it is an orchestration platform for managing the containers. Okay, so when we learn about Ansible and Terraform, we learn about this. Okay, immutable and infrastructure, and mutable and declarative and imperative. Okay, so what does the immutable infrastructure? Okay, without alteration, one should be able to manage the infrastructure. Okay, that is immutable, and with changes, that is called as mutable. And what does the declarative means? Means will not give the step-by-step process or steps in which we give in imperative way. Okay, in declarative, will define that achieve the desired result. Okay, so by allowing the deployment of containerized application, okay, through declarative configuration, rolling updates, version release, and management desire, and the management of desired replicas, Kubernetes adheres to the concept of immutable infrastructure. Okay, so Kubernetes helps us in having an immutable infrastructure, and it is in declarative in nature. Okay, so we'll be defining some YAML files as well in Kubernetes, which will help us in achieving the desired state. That is, in short, it is declarative. Okay, so there are various providers for Kubernetes. Okay, so one of them is Docker Swarm, Apache Mesos. These are some of the famous ones. Okay, these are some alternatives to Kubernetes, you can say. So generally what happens, first we learn about Docker, then we learn about Docker containers, uh, Docker compose, and then we learn about Docker swarm, and then Kubernetes. But now as Kubernetes is mostly used, okay, we skipped Docker swarm. Okay, so this is the path everybody follows, but we have skipped this Docker we have skipped, and Docker is from the Docker company itself, Docker swarm. Okay. And as I said, it is useful for scalability, service discovery, networking updates and all. So Kubernetes is mostly used for that. And there are various ways to install Kubernetes. Okay, like there are various Linux operating system like Ubuntu, SUSE, Red Hat. Similarly, Kubernetes has various ways to installation, and there are various providers. Okay, one of them is vanilla Kubernetes. Vanilla Kubernetes means something which is unaltered. Okay, so everyone is using this vanilla Kubernetes. Okay, which is installed using a tool called kubeadm. That's why it is written as vanilla Kubernetes using kubeadm. So vanilla Kubernetes is the one which is released, which is open source and released, and on the top of that various companies are creating their own Kubernetes infra or provider. Then Minikube is one of them. Minikube, MicroKTS, K3s, K0s, and Kind. Kind means Kubernetes and Docker. So it is possible to install Kubernetes itself in Docker. Okay, these are for learning purposes. Okay, whatever I have written in the bold letter, these are for learning purposes. Then VMware has VMware Tanzu. SUSE has Rancher Kubernetes. Then Google has Google Kubernetes Engine. EKS stands for Elastic Kubernetes Service. So we'll be learning from today EKS because it is AWS DevOps course, and AKS is Azure Kubernetes Service. Then there is OpenShift, Rancher, Anthos. These are on-prem, or you can say which can be installed on bare metals and all. Okay, so these are various Kubernetes, okay, providers, and GKE, EKS, and AKS. Okay, that is Google Kubernetes Engine, Elastic Kubernetes Services, and Azure Kubernetes Services are managed service Kubernetes services. Okay, so why they are called managed? It focuses on simplifying Kubernetes cluster management. Okay, managed means I'll explain it in some time when we go into the architecture of Kubernetes, but most of the cloud providers have made it very easy to deploy Kubernetes, okay, and to deploy application on those Kubernetes servers. Okay, and similarly, as I said, OpenShift and Rancher, these are used for open source. Okay, Anthos is also one of the open source and very famous. Okay, it focuses on hybrid and multi-cloud application. At least you should be aware about these names. Okay, the Kubernetes world revolves around all these providers. Okay, so before learning the Kubernetes architecture, just think of it as it is a crane. Okay, so if you see, here is the logo for Kubernetes. It resembles Kubernetes, this crane. Okay, and if you see, there are containers on the ship. Okay, and these are the containers kept on the ship. So the Kubernetes, what it does, it will pick up the container and place it on some another shift wherever it is required, or on the same ship it will place from one place to another. Okay, that's what the Kubernetes does. Its main aim is to make sure that the containers are running properly. So this is the architecture for Kubernetes. So generally at least one master node should be there and one worker node should be there in Kubernetes architecture. Okay, so the master node means it is the heart of Kubernetes. It manages most of the things. So what it has four main components: Kube API, Kube Scheduler, Kube Control Manager, and HCD. Okay, so whenever we interact with the Kubernetes, we interact via API. Okay, so it exposes Kubernetes API for interaction. So this component exposes the API, and via this API we interact with the Kubernetes cluster. Then there is a component called Kube Scheduler. Okay, What is its role? It assigns pod to the nodes based on resources. So which are the nodes? This is the master node, and this is one of the worker node. There can be multiple worker nodes as well. In this diagram there is only one. So it will make sure that the pods, okay, so we haven't learned about pods, but think of it as containers. So in Kubernetes we call pod as containers. So most of the times we'll be referring containers as pod. So this kube scheduler makes sure that the pods to the nodes are assigned properly based on the capacity of the node. Suppose this worker node is full, then if there is one more worker node, kube scheduler will make sure that it is placed on a node where there is less load. Okay. Then we have kube control manager. Okay. So it ensures the desired state matches the actual state. Okay, so the desired state, suppose it is defined that I need two containers. Okay, and if there is only one container, then it will try to match it. If there is only one container, then it will spin up one more container for it, or a pod, and it will ensure that the desired state matches the actual state. Okay, and HCD, it's kind of a key value store for some cluster configuration. So whatever the configuration will be saving, it will be stored in this database. You can say HCD database. So these are the master components. If you must have seen, most of the pod management is done by this master node. Then we also have the worker node. Okay, worker node is the node where the actual containers run. Okay, it is possible to run the containers on the master and worker node both. Okay, but it is not recommended to run the workload on master node. So by default, on most of the Kubernetes providers, master node will not be used for scheduling the pods or containers. It is the worker node which has the pods running. So it also has three main components. One is kubelet, kubeproxy, and container runtime. So the pod's life cycle is managed by kubelet. It keeps on checking if the pod is starting or stopping, if it should be started or stopped. Okay, that life cycle is managed by kubelet. Then kubeproxy, whatever network communication and routing is required between the nodes and the pods, that is managed by the kubeproxy service, okay, in the worker node. And even for running the Docker container, okay, so Docker is one of the container runtime, but Docker is not the only runtime or the container runtime, but it makes sure that the containers are running properly. So for running the containers, we need a container runtime on the worker node. So one of them is Docker, okay, other one will be containerd and cryo. These three are very popular ones. Okay, in this I have given example of Docker. So container runtime is required on the master node, on the worker node, to make sure that the containers run properly. And in any DevOps interview question, if it is related to Kubernetes, they will definitely ask you the architecture of it. Okay, so that's why I have given it in a very short format. At least this much they are expecting. Okay, one liner explanation for each. Okay, and they will ask you what are the various other container runtimes which are possible apart from Docker. So containerd is one of them, and other one is cryo, cryo. So the same thing is explained here, the master node components, okay, the worker node components. So we have learned about this. So what is pod? Pod is the smallest deployable unit containing one or more containers. Okay, so pod, you can say it may contain single or multiple containers as well. Okay, and even in this architecture, there are few things which which are not shown in there. Okay, but we'll be having some controllers. So these are inbuilt. Okay, so what are those controller? One of them is replication controller. It is used for keeping the replica count. Okay, and it is the replica set is the improvised or improved version of a replica controller. This was the older one. Okay, so as I said, there will be multiple copies of the containers or pod. So that replica is maintained by a replica set. That is one of the controller inside the Kubernetes itself. Then the deployment, okay, it manages the pod lifecycle and updates. Okay, Then there is a concept of stateful and stateless. We haven't learned about it. We'll learn soon. So for that also there are some controllers. So these are inbuilt controllers. Okay. Then we'll be deploying some applications on this Kubernetes cluster. Okay. And after deploying the application on this Kubernetes cluster, we need to access it. Okay. For accessing also, we'll be needing different services. Okay. So cluster IP, node port, and load balancer. Okay. These are some services, and ingress is also one of the service which helps us in accessing it from the outside world. Okay. Then we'll be learning about the config map and secrets. Okay. So the configuration data and some sensitive information, how to store, all these things we'll be learning. Okay. But at least this much we should be uh, able to remember. What is services? There are three types of services: cluster IP, node port, and load balancer. And from outside world, for routing purpose and all, we'll be using ingress. Then what is config map? For storing some configuration data, we use config map in Kubernetes. Okay. And to store some sensitive data, that is password and or secrets and all, we'll use secrets. So the same architecture I have again given here. Okay. So API, HCD, scheduler, and control manager, these are these are master node components. And we have even the worker nodes. The worker node can be even single worker node, or there will be multiple worker nodes. Okay. And on each, three services will be running: kubelet, kubeproxy, container runtime. Okay. And even the master nodes can be multiple. Okay. In case master node fails, it should also be in a highly available mode. So what happens is, in cloud we have multiple availability zones, right? US East 1A, B, and C. Okay. So most of the times the master nodes will be in a high availability mode. In the one master node will be in US East 1A, other one will be in 1B, and the third one will be in 1C master node. And similarly, the worker nodes can also be placed in 3 availability zone or 2 availability zone, however we want it. Okay. And what is this Java, PHP, Node, and Python? These are, you can say, multiple pods based on the programming language on which the application is written, that those pods or containers are running on it. Now, one of the most important, this is for general knowledge. Okay. But you should you'll be hearing about these things, okay, when you read about Kubernetes or when you learn about it. Okay. So everything is about containers. Okay. And there were some misuse of this uh, containers. Means somebody came up with some different kind of container, and it was not easy for others to use it or to get the documentation and all, and they tried to monopolize the market. Okay. So some companies have come together to agree on some standards to make ecosystem interoperable, and there is no dependency on a single vendor. Okay. This is important. So to avoid a dependency on a single model, in short, they have created a standard which every new provider, container provider or a Kubernetes provider, should follow, so that everyone is on the same page. Okay. There is no monopoly or no dependency on a single vendor. Okay. So what are those standards? One is Open Container Initiative. Okay. This is a group of standards for containers that cover distribution, runtime, and image format. Okay. So when we created Docker images and all, so that is also one of the image format. That's what it is referring to, OCI. Then we have Kubernetes Container Runtime. Okay. It is an API that enables the usage of various container runtime. Okay. So Kubernetes has a CRI. Okay. These are some components which we cannot see, but they follow some standards. Then the CNI for network, the same thing for network, standardization of network on Kubernetes or on container. Then CSI, container storage interface. Okay. Suppose you want to launch your own product, okay, which is containerized or Kubernetes based, then you should adhere to this container standards. Okay. So some of the examples of OCI, okay, that is Docker, Rocket, and Podman, they follow the OCI standards. Okay, some examples of container runtime interfaces: Containerd, CRI-O, Docker, Kata containers, gvisor. Okay, then some of the CNI container network interfaces and Calico, Flannel, Weave, Cilium. These are very famous. Okay, so whenever will be installing Kubernetes at the backend, one of the container interface will be installing. Then some storages. Okay, so we know that Docker needs a persistent volume, like any container needs persistent volume. Okay, so there are various options. We have seen one of the Docker we saw with Amazon EBS, right? Then CAPH, Amazon EBS, Google Persistent Disk, NetApp. Okay, these are some of the examples of CSI standards. They follow the CSI standard. Okay. So what is the benefit of Kubernetes? One of the most important, even I feel, it is auto healing feature. Okay, container self heal by restarting, rescheduling, or replacing. We'll be seeing this. Okay, due to some reason, if the container dies or it gets restarted or it is not responding, Kubernetes will auto heal it. Okay, scalability, horizontal scaling. Okay, it is possible from UI and GUI both. Scaling means, uh, suppose the workload is less, then we can have two pods. Okay, if the workload increases, it should automatically increase, the number of pods should increase to 4 5 or whatever we have defined. Okay, we can do that manually as well as automatic. So scalability is one of the feature. Then rollouts and rollbacks. Okay, so due to some reason, whatever we have deployed is not working properly, then we can revert to the previous state. That is rollouts and that is rollback actually. Rollout means deployment and rollbacks means if it is not working properly, revert to the previous state. Then the service discovery. Okay, so if there are many containers, it is difficult for us to discover or find the pods and all. So Kubernetes finds it on its own. That is the service discovery feature of Kubernetes. Then the storage orchestration. Okay, we have to manage various storages. Kubernetes helps us in that. Secret management, config management. Okay, and so many things we can do with Kubernetes. So there is also a limit on number of pods and nodes. Okay, so if you are interested, you can go through this link. It is also given in our wiki page. Okay, so as per this 1.28, okay, version 1.28, now 1.30 is the latest version of Kubernetes. Okay, so if you see, not more than 110 pods per node, not more than 5,000 nodes can be there, not more than 1,50,000 total pods. So there are some limitations, but I don't think we'll face that. Okay, but at higher level or higher overview, we should know that there are some limitations on number of pods and nodes. Okay, now there are various options to install Kubernetes. So there are different vendors or different providers for Kubernetes, and the installation steps also will vary. Okay, so self-hosted Kubernetes cluster. Okay, that means if you want to install it on your laptop or on a VM, okay, then that is called as self-hosted. For that, some tools are used like kubeadm, kops, rancher, kubespray. Okay, these are some of the self-hosted, or you can say on-prem. Okay, then there are cloud-hosted Kubernetes cluster. Okay, that is a managed one. Okay, managed service offered by cloud providers. So all the three main cloud providers, you can say, they provide Kubernetes. Managed Kubernetes, I'll explain what does the managed means. Okay, so EKS, GKE and AKS are some of the cloud hosted Kubernetes cluster. Then cluster as a service. Okay, so some of the providers are also providing in their cloud infrastructure cluster as a service, DigitalOcean, Linode, Platform 9 and all. And for our learning purpose, we can install MicroKTS, Minikube and Kind. Okay, but today onwards we'll be seeing about Amazon EKS, okay, Elastic Kubernetes Service. Okay, and here, as it is a managed service, now what does that managed service mean? If you come to this architecture, okay, so as I said that we need a master node, we need to install a master node. It can be VM or a physical machine. Then we'll need worker nodes. Okay, this also can be can be a VM or a physical machine. So in a managed Kubernetes service, okay, this master node, whatever number it may be, if it is in highly available mode in 3 zones, there will be 3 master nodes. They will be managed and installed by cloud provider, that is AWS in our case. Okay, and we will only manage the worker nodes. Okay, this is important. Okay, when it is on-prem, we need to manage everything. We'll install master node, okay, and worker nodes both. In cloud, okay, the master node is installed, we cannot even see it. Okay, but it exists, but we cannot see it. We only see the worker nodes. Okay, we'll be interacting only with the worker node. Master node patching and all, or updation, upgradation, if it fails, everything is the responsibility of the cloud provider. In our case, AWS will be managing the master node, and we'll be managing the worker nodes. So worker node is our responsibility, patching it, updating it and all, but the master node will be done by the cloud provider. That's why it is called as managed Kubernetes service. Okay, so management, it doesn't mean that we cannot manage it. Manage means the master node will be managed by Kubernetes. So this we are not covering. This is for on-prem. So we'll be covering about EKS. Okay. So today we'll be doing the installation of EKS, Elastic Kubernetes Service. Okay. It is a managed Kubernetes service offered by AWS. It helps us in deploying, managing, and scaling containerized application. So what are the advantages? As we do not need to manage the master node, okay, it is very easy. We can concentrate only on our deploying the applications. Okay, so most of the cloud providers have made it easy. Okay, so if you see, most of us want to be a infra engineers, but the infra work is mostly now done by the cloud itself. Okay, so we need to concentrate more on the DevOps work. Okay, that is writing the Kubernetes manifest and all, we'll be seeing soon. So it helps us in simplifying the Kubernetes management, easily scale. We can scale the application. Okay, we can integrate with some other AWS services, and we can use the security of the cloud itself. Okay, like IAM and role-based access and all, and flexibility. Okay, we can so it is also possible to run EKS on-prem as well, okay, for hybrid connectivity and all. So that's flexibility is saying. And who should use EKS? Developers who want to leverage Kubernetes advantage without managing the underlying infrastructure. Okay, so it is very easy to install EKS. Okay, so we do not need to manage the underlying infrastructure. Means to some extent only we need to manage, not much. And the organization that needs scalable and secure platform for deploying containerized application, and maybe some people have already using AWS. Okay, so and then it is a better idea to go with EKS rather than for any other EKS Kubernetes provider. Okay, so we'll start the EKS installation now. So for that we'll need AWS CLI. Okay, we all know how to install AWS CLI. Then we will be using a method of installation that is using EKS-CTL. So it is one of the command line tool. Okay, it is recommended to use EKS-CTL, okay, command line tool to install the Kubernetes service. So this command will download EKS, okay, and using EKS-CTL will create a Kubernetes cluster.